Okay, so today we're going to talk about factoring, and we've already done some. And so, as you look at this section, you're like, okay, great. Well, if you factor out a 3x, you're left with x minus 2. It's a 1 parenthesis factoring. This is the difference of two squares. It's 2x minus 9 and 2x plus 9. And the next one is x and x, negative 6 and positive 1. If you rainbow it, you should get the middle term. The product of the first makes the first, the product of the last makes the last, the rainbow makes the middle. The last one, do you see something you should do first? Well, if you take it a 3x, then you'll get 2x squared minus x, and then minus 15, who will factor cuter. And so that's going to be 2x and x, and then 5 and 3. And bring down the 3x in front. Okay, so when you take out a GCF, you just bring that down to the front. One thing we're going to talk about is, how do you factor different things? And so today is going to be kind of a journey into that. And so, if you looked at number 2 and you said, hey, let's factor it by grouping, you cut it in half and you do the GCF of the first half. You're left with x minus 2. You take out a negative 1. You're left with 3x minus 10. Notice these groups don't match, do they? So this one doesn't factor by grouping. So what do you do when you've got a polynomial who doesn't factor? Well, sometimes you just solve it a different way, but one way to factor is to do synthetic division. And so you could put negative 2 in the box, and you would put 1, negative 2, negative 3, and then 10, and you can bring this down. You can multiply, you get negative 4. You can multiply again, you get 3. Actually, I lied. You're going to get 8. So 4 times 2 is 8. Pardon me. And this will give us a 5. And then if you multiply by negative 2, you get negative 10. So this goes in evenly. Okay, that was a question I asked you guys to say, hey, what does it mean if you can divide a factor into evenly? Well, that means it's going to be a factor of the original polynomial. So the factors that multiply to make the original polynomial, that 4-term polynomial, would be x plus 2 times x squared minus 4x plus 5. And notice this is the factored form of this original polynomial, which is really kind of a weird thing. Okay, and so this would be the factor of it. Notice it doesn't factor by grouping, does it? And so today, as we talk about factoring, we're going to be reminded that factoring always begins with a GCF, and sometimes that's the only thing you can do. Always start with the GCF first. Now, after you do that, you might factor another way. If it's got 2 terms and it's the difference or subtraction of 2 perfect squares, it's going to be the difference of 2 perfect squares, and we factor that a bunch. Something new is if you've got 2 cubes that are subtracted or added. Okay, cubes are 3-dimensional figures where you multiply the length and width and height, which are all equal together. So a cube would be like 8 because 2 times 2 times 2 makes it, or 27 because 3 times 3 times 3 makes it. And so if you have the sum of 2 cubes or the difference of 2 cubes, you can factor it. And I'll teach you how to do that today. It's kind of a weird situation. We did trinomials before. We've done those. We're going to keep on doing those. And then coefficients bigger than 1. Remember, they have to multiply back to get it. If you have 4 terms, sometimes you can factor those by grouping. And then factoring by synthetic division, big old stinkers, okay, that we can't factor in one of those methods. Sometimes we're going to use synthetic division to force things to factor. And so that's going to help us to factor things into polynomials. So the first thing we did was we said, let's factor by grouping. Okay, and so remember, factor by grouping, it splits it into 2 groups. And so I just had students in class do example 3, or C, pardon me, and E. And I want you guys to look at this and see, you take out the GCF of the first half, so it's x squared, you're left with x minus 2. And in the second half, if you take out a negative 9, you're left with x minus 2. So you get x minus 2 as your first factor, and x squared minus 9 as your second factor. If either of those binomials factors further, you should. So x squared minus 9 does factor into x plus 3. Notice it's the subtraction of 2 perfect squares. So the factors that make this original polynomial would be these 3. Okay, so just check to see if you can do that. Another thing I would say is if you've got 6 terms, again, you split it in half like a sandwich. Take out the GCF of the first half. In this case, you could take out a 6x. You're left with 5a minus 4b, and then plus c. And in the second half, you take out a negative y squared. And you're left with 5a minus 4b, and then plus c. Notice the two parentheses match. So your first answer will be the GCF, so 6x minus y squared. And notice that's not the difference of two squares, so we can't factor it further. Your second parenthesis is 5a plus 4b plus c. And so that's going to be your answer for the factored form of this. So if you want to practice the other ones, you're welcome to, but that's the main gist of it. Difference of two perfect squares, that means it's got to be the difference or subtraction between two perfect square terms. And we're going to be bringing things up a notch and be like, okay, well, this is a difference of two squares. Why? Well, because it's subtraction. Okay, here's the first one I did for you. Well, what times what makes x to the 6? Well, x cubed times x cubed. Because remember, when you multiply variables, you add their exponents. And then plus or minus 7, because your rainbow would make 0x cubed. Okay, and so absolutely this is the right way to go. And neither one of those is the difference of two squares, so it will not factor further. This last one, if you take out a 3, you can be left with 2x 25x squared to the 4, sorry, minus 16. You can almost read that. It says 25x to the 4. So that factors further. It's the difference of two squares. So it'd be 5x squared times 5x squared minus 4 and plus 4. And then also a 3 at the beginning. So you take out a GCF if you can, and then look at it to say, okay, what else can I do? Is it the difference of two squares? And if so, then go ahead and do that. Our next ones are going to be perfect square trinomials. And so if the first and last terms of your trinomial are perfect squares, well, then you can factor it into a perfect square or into two binomials that match. So it'd be 2x and 2x, and then negative 5 and negative 5. Check your rainbow, make sure it actually works. So it's negative 10x and negative 10x. That does make negative 20x. One of these is actually an intruder. It is posing as if it's a perfect square trinomial, but it's really not, okay? And so as we look at this also is a perfect square trinomial because it's x times x. Those are perfect squares, 1x and 1x. 1 is a perfect square, and then plus 6 and plus 6. If you rainbow it, you get the 12x in the middle. This next one, okay, you're like, all right, 5x minus 4. Check it. You get negative 20x and negative 20x. Does that make our middle? No. So this does not factor that way. It's an intruder. Okay, so you always need to check to see, does it actually work? Did I do a good job? Is it truly a perfect square trinomial? So don't fall in the ditch and be like, oh, got it. This is 3x plus 5y. And then again, 3x plus 5y. And if you check it, you'll see the product of the first does make 9x squared. The product of the last does make 25y squared. And the rainbows are both 15xy. So 15xy and 15xy also make 30xy. So that's nothing really new, but just kind of confirming to say, hey, perfect square trinomials do this. Okay, the next part is going to be kind of a big girl factoring or big guy factoring. It is similar to what we've done before, okay? So x squared and x squared make x to the 4th, okay? And then also, how do you multiply to make negative 24 and rainbow to make negative 5? We'll try negative 8 and positive 3. Your rainbow really, truly will be negative 5x squared. And so that's really how you factor it. Same with this one. It will factor how? Well, x cubed times x cubed makes x to the 6th. And then also a positive 1 and a positive 4 will rainbow to make our 5x cubed. So these are a big kid step forward, but they're very similar and parallel to what we've already done. This next method is going to be new and different. And so if you've got cubes, again, a cube is a three-sided or a six-sided figure that has 3 dimensions that are the same. And so a cube number would be 8. Why? Because 2 times 2 times 2 makes it. And then also 27 would be a perfect cube because 3 times 3 times 3 makes it. 125 would be a perfect cube because 5 times 5 times 5 makes it. And so if you have 2 cubes that are added or subtracted, you can factor that, okay? And here is the algorithm to make it happen. Now, a lot of kids really, truly struggle with this because they think that probably this answer to like example A, we'll skip to that, is just x minus 4 times x minus 4 times x minus 4. Okay, so when you want to to factor, the difference of two cubes or the sum of two cubes, here is the algorithm we're going to use. You basically are going to say, I'm going to take the cube root of that first term. Okay, so like a cube, you know how to find the volume, you do length times width times height to find the volume. So to find the cube root of 8, what times what gives you 8? Well, that's 2. And so 2x is going to be the cube root of 8x cubed. And then the cube root of the negative 27 is going to be negative 3. So the sign between them kind of falls. Okay, so the cube root of 27 or negative 27 is negative 3. So it should be 2x subtract 3. And then you essentially cover up this, okay? And don't even think about it. So to get that trinomial, the trinomial is not just 2x minus 3 times 2x minus 3. That's not what the trinomial is. That's not at all. It's going to be, you get it by taking that first term, 2x, and you're going to square it to get it this. So you take 2x times 2x is 4x squared. To get the last term, you square that term as well, and it's always positive. That's where the AP starts for. So you square the first term, you square the last term. The negative 3 times negative 3 makes 9. It's always positive. And then to get the middle term, it's a little weird. You take these two values, the 2x minus 3, you times them. So you can take negative 3 times 2x or 2x times negative 3, you get negative 6x, and you do the opposite sign. And so you put it right there. So that's where the O comes from. So you do 2x times 2x is 4x squared. You negative 3 times negative 3, which is 9. And then to get the middle term, you multiply these two terms together and do the opposite sign. And again, this trinomial will never factor. So many kids are like, oh, it's 2x minus 3 times 2x minus 3. I'm like, no, that is so not true. If you multiply that out, you will not get that trinomial. And that trinomial will literally never factor. So don't even try. Don't even worry about it. It's not going to factor. Okay, so to do this, if you've got two cubes, you take the cube root of the first term. Okay, so on 125x to the third, well, it's going to be 5x, because 5x times 5x times 5x, times itself 3 times, is going to give you that 125x cubed. And then to get y cubed, it's y times y times y. Okay, and then you cover this up. You're like, okay. You square the first term to make the first term of the trinomial. To square the last term, times it by itself. It's always positive. And then to get the middle term, you times these together, 5x times y, and then you do the opposite sign. And so, that's what we're going to do here. So try some of these things. Pause the video if you need to, and you can pause it and say, okay, how would I even do this? And so these binomials would be the cube root of each. Okay, so it'd be x minus 4, bring down the sign. Then you square the first term as x squared. You multiply them together and change the sign. So it's plus 4x, and then plus 16, because you square the negative 4. Okay, and so if you've got two cubes that are either plus or minus, it doesn't matter. You're going to get 2x plus 3, and then you square the first, you get 4x squared minus 6x, and then plus 9. Next one is going to be 5d minus 2, and then 25d squared plus 10d, and then plus 4. The last one over here, you're going to take 2 first. So if you take out a 2x squared, you're going to be left with x to the third minus 8. Okay, and that will factor into x minus 2, x squared plus 2x, and then plus 4. Remember, the middle term is always opposite, and put the 2x cubed squared first. Sorry. Okay. If you want to try the next one again, try the GCF first. You can take out a 3x squared. You're left with a 8x cubed plus y cubed. And that'll factor into 2x plus y, and then 4x squared minus 2xy, and then plus y squared, sorry. Bring down the 3x squared. It is an algorithm type thing where if you follow the steps, you're going to be fine. You get 2x minus 5, 4x squared plus 10x, and then plus 5. Those are your things. And again, that trinomial will never factor. It is not comprised of 2x minus 5 times 2x. That is not the case. If you try that, you will not get that middle value there. So you can try it all you want, but it will not factor. So our last thing is moving towards solving, okay? Notice these are polynomials to the 4th power, the 5th power, and the 3rd power. And we're looking to find all the roots that we're going to be given to this. So the first one's going to have 4 answers. The second one's going to have 5. The last one's going to have 3. And so there could be duplicate roots. I mean, there could be real answers. There could be imaginary answers. So we just want to find them. Okay. And so one way that we do it is factoring. And so if you factor this into x squareds, okay, and then minus 4 and minus 25, this one, do you notice both those parentheses factor further into x plus 2 and x minus 2, x plus 5 and x minus 5. Remember, if it's x squared minus a square, it'll factor further. So the difference of 2 squares will factor further. If you had the sum of 2 squares, it would not factor further. So you get x equals plus or minus 2 and x equals plus or minus 5. If you look at the graph of these, you will notice it crosses at each of these values right here. Plus or minus 2 and plus or minus 5 would make like a W. Okay, so that's really, if you graph this related function, you would see it crossing at those 4 points. The next one, take out a y first. If you take out a y, you're left with y to the 4th minus 18y squared, and then plus 72. Well, she's going to factor into y squareds. And then it's also going to make minus 6 and minus 12. That's a 12. Not a good 12, but it is a 12. And then the thing is, these don't factor further. And so we can still set each factor equal to 0 and solve for what y is. That is my cat screaming. And so, and zooming across the board. If you set y squared minus 6 equal to 0, you get y squared is equal to 6. Square root both sides, you get y is equal to plus or minus the square root of 6. And so you've got 0 plus or minus the square root of 6. So it's an irrational value. If you do this when you get x squared equals 12, x equal to plus or minus square root of 12 breaks into 2 and square root of 3. Sometimes you get imaginary numbers, so don't worry. You know, if you had the square root of negative 12, it would be plus or minus 2i squared of 3. So just breathe. We're trying to account for solutions, whether they're real or imaginary. And unlike yesterday, where we used our calculator to give us decimal approximations, we're looking for the exact solution. So the rational exact solutions. And so that's why we use factoring instead of just a graphing calculator. This one, if you graphed it, you would notice it would cross just at one spot. Okay. One of the answers is real and the other 2 are imaginary. And how you get this, people always put plus or minus 4. I'm like, does that actually check? You know, try 4 to the 3rd and then subtract 64. Does that actually work? Well, yeah, it does. You get 64 minus 64, that is 0. But what if you tried negative 4? You'd get negative 64 minus 64. Is that 0? No, not in this country. You know, so the thing is, 4 is a solution, but how do you find the solutions to this problem if it's not plus or minus 4? That's the common wrong answer that people do. Well, it factors. Remember, we learned how to factor it today? You got x minus 4 parentheses, and then you square this, add 4x, and then plus 16. Remember, you get the trinomial, and this will never factor further. Well, okay, well, this gives us the 4, which we already called out or before, but how do you solve a quadratic? Well, you can graph it to find the real answers. You can take the square, use the square root property. You can do completing the square. You can do the quadratic formula. I'm going to go with the quadratic formula. So you can do opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, and 16 minus 4 times 16, that's going to be negative 48. So we're going to get an imaginary number. Yes, every time you solve a cubes problem, you're going to get 1 real and 2 imaginary answers. And so it's negative 4 plus or minus, square root of 48 is going to be an I, right? But it's 16 times 3, so it'd be 4i squared of 3. And each one's going to be over 2. And we reduce it to give you, let's see what this is going to be. X is equal to negative 2 plus or minus 2i root 3. So those are 2 answers, negative 2 plus 2i squared of 3 and negative 2 minus 2i squared of 3 and 4. So I can highlight these answers for us. So here is one of the answers and here are the other 2. Okay. And then this one has these 2 here and this one has these 4 right there. So that is our answer. Thank you so much. Have a